afternoon, everyone, and welcome to the latest of our GeoTalks Express series. It's been well over a year we've been doing these, and I'm very surprised that it's taking us this long to start talking about raster data. So as you can see on the screen, we're going to be introducing Global Mapper's raster processing functionality, of which there are many aspects. In researching the content for this, I learned a lot. I learned a lot about some of the kind of deep capabilities of the software. Mackenzie Mills is joining me today for this session. Good afternoon, Mackenzie.
Good afternoon, David, and hello, everyone.
Glad to have you with us. Now, we will be collaborating a little bit, and those of you who have been through these sessions before, we'll be switching back and forth a little bit. Mackenzie will be driving some of the presentations, some of the scenarios, and I'll be doing the same. In the meantime, we will try to address some of your questions, as we'll talk about in just a second when we get into some of the housekeeping issues. So we'll try to keep this as interactive as possible, allowing you folks to ask whatever questions are necessary. Before we get started, again, the obligatory housekeeping issues. This is a webinar, and I know many of you have been through many webinars over the last year. You are in listen-only mode. We can't hear you. However, again, if you have questions, over there on the right side of your screen when you launch GoToWebinar, you should see a panel. That panel includes a questions tab. That questions tab is where you can ask your questions in written form, obviously. On my second monitor in front of me here, I have that questions panel expanded, so I will see all of those questions as they come in, and I'm assuming that Mackenzie has the same. So any questions you ask, we will try to answer in the context of when the question was asked. We have a very large audience today, so with apologies, we may not be able to answer all of your questions. But if we don't answer them in real time, we have been following up with these sessions. We will send more direct communication to you to make sure your question was answered. I think we'll also post the questions on a blog so you can read all of those questions and answers at a later date. But again, keep those questions coming in. We'll answer them when we can. The session is being recorded, so if you want to recap some of the content that we're covering, this will be posted within the next few days. A little bit of scrubbing to kind of clean it up a little bit, but you'll see this on the GeoTalks playlist. If you're having subscribed or registered, you will be given access to that, not only for this session but also for previous sessions. Yeah, you'll see the recording, and obviously if you're watching the recording of this session, thank you for watching the YouTube recording or the video recording. Obviously questions are not an option, but we'll give you an opportunity at the end to ask questions via email. Again, I'll provide that email address at the end, and it's also in the description right down below. Just again, a few things about what's coming up on the horizon, the immediate horizon. Some other sessions, some other GeoTalk sessions coming up. We're doing one session a month now. Next month into June, I can't believe it's June already, but into June, we're going to be talking about point cloud data, LiDAR and other point cloud data sets. And specifically in this one, we're going to talk about quality improvement or quality QC. A number of tools have been added to the LiDAR module recently to improve LiDAR quality or point cloud quality, and we'll showcase some of those, not necessarily getting into the analysis tools or the extraction tools, but specifically looking at those QC tools. July session is going to be a collaborative event with the folks at Datum. We're going to introduce a Global Mapper extension and show how they're using that extension with their application. This is a big one. Towards the end of August, we're going to be giving you a sneak peek at some of the new tools that are going to be introduced in version 23 of Global Mapper. Now, version 23 will be released sometime in September. I'll give you a little teaser here. We're going to be introducing a brand new kind of structure to the software. We're introducing a professional version of Global Mapper. I'm not going to say any more for now, but obviously we will be introducing more details as an ongoing, on an ongoing basis, but also come August, we'll actually showcase some of those tools coming up in the release. All of the information about these and indeed registration is available on the website you see right on my screen right now. We have a couple of training classes coming up within the next month, June 14th to 18th. That's a week-long session. We have 3-hour sessions every day. Global Mapper, June 14th to 18th. LiDAR module, June 22nd, 24th. I've had a few questions recently about structured training. Hopefully you're getting our emails. These are hands-on interactive sessions, instructor-led. We use a similar platform to what we're using now, a little more interactive questions and answers, and a lot of the folks who are attending these classes get a lot out of the training, or are able to use the software more effectively. I should mention about these classes, they are evening sessions, targeting specifically maybe folks who are in different time zones. So for those of us here in the Eastern US, it is an evening session. Maybe folks in the Far East, it's a little more user-friendly, or even the West Coast of the US. So information again is on our website if you want to see what we'll be covering in the training, and indeed to register. You'll see information right there. Today, what is the plan? Well, again, our focus is primarily on, well, yeah, it is primarily. We will be deviating slightly as we go through our workflows to talk a little bit about vector data, but it's almost all about raster data. We're going to begin, as we do with many of these sessions, with the basics. What is raster data? I know most of you are very aware of what raster data is. I'm assuming that there are those who are maybe fairly new to GIS, and maybe we need to put this in a little context. So we'll talk a little bit about the structure and characteristics of this type of data. Where do you find it? Where do we get raster data? Where does it come from? And this is going to be a very brief component, but we'll talk about some of the sources of raster data, the online sources, maybe file formats you work with. We're also going to introduce a component of Global Mapper that lets you take imagery and create a raster layer from that image on geographically referenced data that becomes geographically intelligent. Mackenzie's actually going to go through that workflow, and a little sneak peek or screenshot there on the right side shows the actual file we're working with. Those of you who are familiar with this may recognize the area around Boston. We're actually going to use this historic map and rectify that or align it using a rectification process. We'll go through a few different workflows where we talk about editing raster data. Now, as I said in the abstract, if you read through the abstracts, we tend to think of raster data mostly as kind of dumb data. It's a base map. It provides a visual context for the real work that I'm doing, which ultimately is in vector data. Well, raster data in and of itself has intelligence, and there is a little bit of interaction can be applied when working with raster data, including many editing procedures, and we'll introduce a few of those. We'll also talk about some of the tools we have in Global Mapper for analyzing raster data. This is where we get into things like raster classification and calculation tools. So this is more than just a base map. We're talking about more than just a visual reference, but actual intelligent data that we can work with and we can analyze. And time permitting, we'll go through a number of workflows where we'll illustrate these processes. To wrap up our session at the end of this hour, we'll talk about exporting raster. Now, we're going to spend a lot of time, but it is worth noting that any procedures you apply when working with your raster data, whether those are editing procedures or analysis procedures, can ultimately be exported. So Global Mapper can be used for obviously rendering or importing data, but also for exporting your data. So the first one of my bullets there is, what is raster data? Let's take a quick look here. Now you'll see kind of a low resolution screenshot over there on the right side, but it's good as an illustration, because if you look up close on your screen, you'll see that that image of looks like a highway intersection here is comprised of little blocks. Those little blocks, as we know, are pixels. Pixels are what comprise a raster layer. And this is something that I learned during the preparation for this session, where the term raster came from. I've used this term for many years, but I never really stopped to think of what it means. It's actually derived from the word for a rake. And it was first used kind of old school television technology, where you're projecting or raking an image onto a cathode ray tube. Those parallel lines inherited the term rastum, or raster as it became, to kind of illustrate or describe the process of those parallel lines. So raster, the term raster, is derived from that. Now, we've obviously applied the term raster to the derivative data, the array of pixels that we're going to be working with today. So raster data is an array of pixels or picture elements, each of which contains a numeric value. Now, in most cases, and what most people are probably familiar with, those pixels have a color value. If I was to zoom in very close to that image on the right side, we would see each of those rectangular objects would have a picture. A color value. There are other variations on that theme. The value that's associated with a pixel doesn't have to be a color. In fact, in many cases, it's not. And we will see many of those examples today, working with different types of raster data where the value is something else that's measured or quantified. Common use for this is for elevation data. I know many of you have attended some of our sessions where we talk about terrain analysis. Ultimately, we're using raster data, but where the inherent value in a pixel is a height value, Z or Z value, not an actual color. Now, today we're going to be dealing primarily with standard raster data where the pixels are colors. Pixel size is important, and a quick transition on my screenshot here shows a crisper image. What I did there was transition to a higher resolution image. What is the consequence of that? Well, obviously I can start to see vehicles. I can start to see even the lines on the highway intersections here. So resolution is important. That pixel size reflects how much I can see. It also reflects the size of a file that you might be working with. So it's a little bit of a trade-off. How much capacity do you have for storing data against how much detail do you really need for any given procedure? So the pixel size reflects the resolution of our data. And my final bullet here, as you can see, pixels can be visualized, it can be edited, and they can be analyzed. And we will go through a number of these procedures today as we introduce Global Mapper's raster processing functionality. Let's begin with the basics. I want to bring up an instance of the software in which I have a raster layer already loaded, a picture. Now, when I first started working with GIS data, the digital imagery and the idea of digital cameras was still a little bit further off into the distance. I'm giving a reflection of how old I am. So the idea of raster data and working with raster data was a relatively new concept, this idea of being able to manage pixels and what's pixels represented. And by the way, thank you for the comment that was applied in the questions panel. Comments are good as well as questions. Somebody reminded us that pixel is short for picture element. So every element of this raster layer is a pixel or a picture element. And we can zoom in a little closer. This happens to be the state capitol building here in the state of Maine. If I zoom in a little closer, you will start to get to a point within your raster data where we start to see those individual pixels or picture elements. And well, depending on your use case, I think in most cases, this is not that useful at this scale, at this from this perspective. You're starting to see the individual blocks. Now, one thing that's noteworthy when we look at our raster data from this perspective is that each of these picture elements or pixels is consistent in its color, or the value that's assigned doesn't change over the extent of that pixel. A larger pixel, therefore, is not going to give you as much detail. Now, we can see some information right away, and we're going to get a little bit into the analysis a little bit later, but as we move around on this layer, bottom left corner of my screen, hopefully you're picking this up on the screen share here, bottom left corner, you can start to see those values, those red, green, and blue values updating as I move my cursor around the screen. Within the extent of one individual pixel, it does not change. The values do not change. So again, getting a quick illustration here of what a raster layer is and the structure and characteristics. Obviously, it becomes more useful when you look at the imagery or the raster layer from a wide perspective. Those pixels, your eye now sees these as one singular object as opposed to individual blocks. So that, again, quick illustration of the structure. Where do we get this data? Where does it come from? Well, at the risk of repeating some of the content that we covered in a recent presentation, a great source of raster data of many types is our online data. And those of you who have used Global Mapper, I'm sure you're familiar with our online data options, which include many different data sets. We have terrain data, again, terrain data being a raster form in and of itself, but we also got imagery, topographic maps. We've got land cover data. You'll notice that was selected before because I actually grabbed some of this data for another workflow. We're going to be looking at some land cover data in one of the procedures we'll follow a little bit later. But lots of raster data is available, initially streamable, but also downloadable. You can save those files out. So online data sources, obviously, great source for many different types of raster data, not just imagery, but other forms of raster data as well. Obviously, it's worthwhile noting as well from anybody, again, familiar with Global Mapper, the expansive list of formats that are supported. Basically, any raster data that you will be working with is supported by the software. Your GeoTIFF, ECW files, Mr. SID files, Many of you are familiar with JPEG 2000, the format that I use a lot. All of those file formats can also be loaded directly into the software. So again, multiple ways of getting your raster data into Global Mapper. A couple of points, bullet points on my notes here worth mentioning. Any of you who are using the pixels to points tool, now obviously that's way out of the context of what we're going to be covering today, but the pixels to points tool is a tool that allows you to generate multiple types of data from overlapping drone images, primarily intended for three-dimensional data, point cloud data and mesh data. But as a byproduct of that, it will also generate an ortho image. So another good source for raster data, for a really good quality base map, if you have those overlapping drone images, is this pixels to points tool. Again, generating an ortho image you can use for a visual reference for any other type of map work that you're doing. So again, quick introduction, just outlining some of the sources of raster data. I'm going to introduce, or Mackenzie's actually going to introduce another workflow that allows you to generate raster data. As I mentioned during the introduction, the idea of rectifying or positioning a picture in such a way that it aligns geographically. Mackenzie, I'm going to give you the screen so you can guide us through this process.
All right, so sharing my screen here, as David said, we're going to walk through a workflow to rectify some imagery. So David talked about what raster data is made of. It's made of pixels, commonly images. Not every image that you encounter is going to have, the georeference, that geospatial intelligence, to be able to be loaded directly into Global Mapper and placed at the correct location. For example, here, the file that we'll be working with, we have an historic map from Boston here. This is from 1842, and this was, hand drawn. It has been scanned or converted to a digital format here, but it is a JPEG image that doesn't contain any georeference. I'm going to close this preview that I have open in my default photo viewer here, and we'll go ahead and try to open this data in my Global Mapper workspace. Now, to note right before we do that, we've got a few different layers in this Global Mapper workspace. I've got an ortho image of the Boston area, and below that, I have some street data for the Boston area as well. And since our historic map, outlines the streets pretty well, we've got Boston Common coming through pretty clearly on both. I'm going to go ahead and use this street data as a tool to help rectify my historic map. So we'll go up to the open data files and find that historic map of Boston and choose to open it in Global Mapper here. So once I click to open this map, we are prompted to choose how we want to load it in Global Mapper. Now, the first option is to manually rectify the image, and that is what we are going to do. The other options here are to fake the coordinates, load the image in at an incorrect location just to view it, or to load the image as a picture point. So instead of projecting it as raster data in the Global Mapper workspace, load it connected to a vector point feature. We really do want to manually rectify this image so we can display it over our current street data in the Global Mapper 2D view here. So clicking OK, we get our image rectifier dialog. And this dialog helps to guide us to place some control points to tie points in our historic image to geographic coordinate locations that we'll choose based on our reference image here. The three panels that we have up at the top of this dialog, the first two are the historic map, that unreferenced image that we're bringing into Global Mapper. Our middle view is our zoomed view. We can scroll to zoom in here and place our control points. And then the third panel on the right is our reference data, and this contains that data that we had previously loaded into the Global Mapper workspace. So I've got that street imagery here. I'm going to go ahead and place a control point. I'm clicking to identify a pixel location in my zoomed view for my unreferenced image. And I'm connecting that to a coordinate location that I'm choosing from this reference image view. Now down below, we can see we've got our pixel X and Y, that index for identifying our point in our unreferenced image, and our coordinate location. We've connected those 2 points, and we would add the point to list and continue clicking to tag more control points throughout this image. You want to evenly distribute them. Now, I'm going to go ahead and load some control points from a file that I previously generated for this historic map. The control point file that I'm loading contains 8 control points, I believe, and we can see the information contained in that file listed down below in our dialog. It's got a name for the point, the pixel location in our unreferenced image, and then the coordinate location that we would have tagged with our reference data here.
Mackenzie, sorry for interrupting. Question came in about that process. Someone asked specifically about the projection, select projection, and what does it do, basically, I guess was the question. This really allows you to define the X and Y values based on those units. So if your projection is defined as UTM, for instance, where you see lat long values entered, you would actually enter those projected coordinates, those linear units in that case, instead of lat long values. So selecting the projection allows you to specify what the projection parameters are, what the coordinate parameters are in this process.
And that becomes even more important if you do already have a list of control points maybe written down that you're entering into Global Mapper. You can enter the pixel values here in these fields and enter the coordinate values as well, whether that's a latitude, longitude, or easting, northing in a projected system.
Sorry to interrupt once again. Someone asked specifically about if you can do a 3D rectification. That would require you to have some 3D data to begin with. So for instance, if you have a point cloud and you want to adjust the positioning of that point cloud on the X, Y, and on the Z or Z axes, yes, you can do 3D rectification. In fact, if Mackenzie had been working with a 3D data set, there would be another field here below the pixel X, Y. There would be a pixel Z or Z value as well. Oh, the question I was expecting came in as well. Sorry, Mackenzie. What's the recommended minimum number? That's a tough one. The minimum number is 2. You can rectify with 2, and obviously in this case it wouldn't be very good because the original map is not projected in and of itself. It's hand drawn, so more control points are preferred. I would say at the very least having 4 in an image like this, starting with 4, determining the result, and then re-rectifying to adjust as needed. Every time you're doing that, obviously you're doing a little more rubber sheeting, a little more distortion. So there is no rules here as far as this is concerned, but I say at the bare minimum with this example, starting with 4 is a good idea.
Yep, and evenly distributing those points throughout the data that you're trying to rectify can help to more evenly stretch and position that data correctly. So now that we've got those control points loaded in, we can see them on both the zoom view and the reference image view. Click OK, and pretty quick Global Mapper should bring that historic map into the 2D view and project it based on the control points that were just defined. Now we can see here that the historic map is at an angle. It's a little skewed, looking at maybe the edges of that rectangle. It's a little stretched in some areas, and that's due to the rectification process, particularly evident with this map because, as David mentioned, it's hand-drawn. It wasn't created with a north-up orientation, so it does appear at a slight angle there with a little bit of stretching to fit the control points that were identified. Now that we've got 2 raster layers, one laid over the other, we can do a little bit of visual comparison between these 2. One way to do that is with the image swipe tool. So from the viewer toolbar, I can pull back the historic map to reveal the more current street data below. Just clicking and dragging, pulling back that map. I could turn on the imagery, that ortho image for Boston as well, and perform the same action, pulling back the map, the historic map on top to see the imagery below, and we can really see how, you know, Boston has been built up quite a bit since 1842, and this historic map was created. Whole sections of the city that aren't included on this map, that didn't exist, that weren't developed, are now, you know, obviously captured in that current ortho image and street map data. Some other options for looking at these different data sets together would be to adjust some of the display characteristics for these data sets. So taking the historic map that's on top, I'm going to open the layer options here, and we can set a little bit of transparency for this top map. So maybe we can start to see the image come through below. I'm just working on this display tab of the raster options dialog. In this dialog, there are a lot of options for adjusting the display characteristics, cropping, and, you know, many other adjustments you can make to that raster image, and we'll get into a few of these options a little more later. Make that a little bit more transparent. And we can adjust our ortho image a little bit too. It's a very dark image. Maybe we want to lighten the color intensity there. So again, I'm going to come back to my ortho image, open the raster options for that layer, and just lighten that color intensity a bit, so we can see the, you know, current ortho image describing Boston with our historic map. So a little bit transparent draped over the top, and we can get a sense of both of these data sets and the boundaries of the rivers and things like that as we're looking at the data here.
And so some people are probably familiar with this part of the world. That area you were describing, Mackenzie, on the west side, at that time was literally part of the Charles River. It has since been filled, and very expensive real estate is now available in that area, Newbury Street and various other thoroughfares there on the west side. So anybody who's walked around Boston, a lot of what you'd be walking on today was at one time underwater. A couple of other questions here. Is it possible to re-rectify? Yes, absolutely. If you, that initial QC process, maybe that image swipe tool or adjusting the transparency to see how well it lines up. If you're not satisfied with the results, as Mackenzie is showing you now, you can right click on that layer and then go back into the dialog box again and maybe remove points. Someone had mentioned about error. The error factor would be available with certain types of rectification, where it would actually tell you, it would give you an indication as to which of the points are contributing to the greatest level of distortion, and perhaps addressing those specifically might improve the output. A few other questions here on that process. How much can you zoom on the historic layer? Well, again, it's going to be reflecting the resolution of the image. Even though the image wasn't a geographic image, it still had its own resolution. So obviously it's going to have a finite range as far as its usefulness. Zoom in closely and you're going to see pixels. It's a pixel-based layer as the underlying data. So you're starting to see that pixelation a little bit as we zoom in. So
another way we can just take a look at this data, sort of any imagery, not just my historic map that I have here, I can turn on an underlying elevation layer that I have. So this is some terrain data with elevation values associated. And if I open this project in the 3D view now, I've got my 3D exaggerated a little bit, and we can see this historic map draped over that elevation data. We can start to see, what is it, Beacon Hill right here, and some other, you know, terrain changes in the background of the city of Boston here. So any raster data can be draped over the terrain in this way to get a sense of some other geographic properties of the area. And it's good to mention that, you know, I've gone through this process. I took this unreferenced JPEG historic map image, brought it into Global Mapper, you know, displayed it at the correct location. And now that I have this displayed in my workspace, I can export it to another raster format and retain that georeference, that rectification work that I did, so that, you know, when I share this map with another user or use it in future projects, I don't have to go through that manual rectification process again. You know, I can work with this just as I would any other raster layer.
Yeah, there's a number of other questions about rectification specifically. Unfortunately, we don't have a chance. We'll be spending the rest of our session just answering those. Some folks asking questions about the technical aspects of this. Last one just came in. Does it transform the raster or just shift it? It transformed it, basically. If you look within the rectification dialog box, maybe Mackenzie, you could open it up just one more time before we wrap this one up. But if you look in the menus at the top, there are more detailed options under the options rectification methods that can be applied as noted here. We typically use the automatic for what we do, just for a quick demonstration, but you can see you can get into more specifics in terms of the underlying math that's applied as part of this process. So we could probably do an entire session just talking about this tool specifically, but unfortunately we don't have that much time because we still have a lot we want to do. So Mackenzie, I'm quickly going to grab the screen back again, and I'm going to show a few very basic raster processing workflows. We've finished with the idea of basically importing raster data or rendering raster data. I want to talk a little bit about editing, and there's a couple of very specific tools I want to show you. I've got a number of instances of Global Mapper kind of running in the background already. These are going to be very quick and dirty. Mackenzie mentioned just a few minutes ago about the idea of cropping data. It was one of the components, one of the tabs that was available in the options for a selected raster layer. I happen to have this. Again, we're in the state of Maine here. This is a little town called Gardner, right in the middle of Maine. I've got the boundary file. This is a vector file. Could be something I imported, could be something I drew, but I can use this as the basis for cropping any loaded raster data. I've simply selected it, and I can go to the properties or the options for that layer and look at the cropping options now. Now, cropping can be defined in a number of different ways. I think perhaps the most common of which is to crop to a polygon that I've just selected, and that's obviously what I've done. You can crop inside or you can crop outside. So obviously, if I want to remove any imagery that's not relevant for my project, not relevant for my jurisdiction, I've effectively done that. I've removed the pixels I don't need. If I exported this data specifically now, it would only export what it sees. If I made a mistake and I realized I didn't need to crop, don't worry. It's not a permanent change. You can go back to no cropping again. So a number of different options here that apply to removing sections of an image that are not relevant. Another edit that we can do is feathering, and this is a more specific type of edit that applies to a situation such as you're seeing on the screen right now, where we have two different raster layers. The northern section is a relatively high resolution, some high resolution data. To the south is a little bit lower resolution, and the consequence of having these two layers, you should see a very distinct and hard border between the two. Any processing we do, any visualization, obviously it's very clear that we're dealing with two different types of data. Simple solution is to feather them, is to basically create a gradual transition from one to the other. Again, a very simple operation when applied as an option within this layer. Feathering is the tool here. Feathering will only work, by the way, if there's overlap, because what it does is it applies a gradual transparency to the layer to which it's being applied, which in my case is my higher resolution data. I want to feather around all four edges based on a multiple of this pixel size. So whatever the pixel dimensions are, it will multiply that, and that is the extent of what will be feathered. I'm going to bump this up to 200 times the size of my pixels. We'll apply that first to see how it looks, and it looks reasonable. So you can see I've got a cleaner transition between these two imagery layers. Now, we haven't magically made them look exactly the same, but at least if I were processing this, maybe exporting it for use in another application, that transitional seam is much cleaner than it was before.
We've got a couple questions that came in here, David, particularly related to cropping. Does the cropping modify that source file, or does it just hide that image, and how can we retain that cropping?
Good question. So the cropping process is, the action of cropping is something that's stored internally only, at least initially. It has no effect on any external files. In fact, that's a rule across the board with Global Mapper. Any modification you make to any data internally is stored internally, but not applied in real time to that source file. In order to apply any changes, whether it be cropping or feathering or whatever, to an external file, it requires an export. So it is a kind of a step required, which is a good thing because it means you're not accidentally changing the data that maybe somebody else is accessing at the same time. So yeah, you're reading the data, applying modifications internally, and then again, based on that cropping, if I ran an export, it would only export the pixels that would be visible on the screen. I have one more quick illustration of an edit that I can apply here. And this is a very specific one. I've got another workspace sitting in the background here. Here we have a panchromatic band from some satellite imagery. Grayscale rendering, as you can see. In this workspace, I also have a low resolution RGB. Now, this gives me the opportunity to perform a process called pan sharpening. What pan sharpening does is it uses a combination of these two layers, a relatively high resolution panchromatic layer with a lower resolution color layer, to essentially create a third layer, which takes the best of both. It takes the colors from the colorized layer, the resolution from the panchromatic layer, to generate one single output. This is an option under the analysis menu. Pan sharpen image, it's listed right here. I'm not going to deal with the details. We'll just click OK, and hopefully we'll see the result. There we have now a pan sharpened imagery, a raster tool. Anybody working with Landsat data, for instance, will be familiar with these individual bands. This is now a tool where we can basically apply color to a higher resolution panchromatic layer using that process. Very simple procedure. And again, if we needed to, we could export this as a new layer through our export process. That was a little bit of a quick whirlwind tour through some edits. Mackenzie, I believe there's one more that you're going to share with us. Mackenzie, during the workflow, when we looked at the rectification, showed us how we can adjust transparency as a way to maybe look at two different overlapping raster layers. There are a number of other tools that will allow you to do that. And I think Mackenzie's going to show us how we can actually blend them together.
Yes, I am. So, bringing up Global Mapper, I have a new workspace open here. And as my screen comes up, we should see that this is a map. This is from a PDF map layer of the Augusta area right near the Capitol. We've got just sort of a plain background with contour lines and roads and a few labels and things like that they're good to know, good to see in our map. Below that, I have another raster layer here, and it is an image, a aerial image of the Augusta area. So, this is more of an ortho image. We're seeing where there's vegetation and the buildings and all that. But both of these layers have good information on their own. But with a blending process, I can look at the information from both layers at once without having to toggle back and forth between them or use that image swipe tool we looked at before. David said that, we did a little bit of that with the historic map and some transparency settings, but opening the raster options for the Augusta PDF map here, we're just going to stay on this display tab, and instead of adjusting the transparency or that color intensity, we're going to move down to the bottom of our dialog and select a blend mode. So here I'm operating on that top layer that we have in our workspace, that PDF map that we're seeing now. And from this blend mode dropdown, there are a lot of different options for how to deal with blending these layers together. The one I will select for this data set is apply color reverse. And as I click OK with that setting made, we should see that imagery coming through our map blended with our PDF map to take the space of the background of our PDF map. So we still have our labels and our roads we can see over here. Faintly, we can still see our contour lines as well, but we're seeing that imagery come through underneath. So we're looking at the important characteristics of both of these maps at once. Another option, another version of blending would be to involve some terrain data again. So quickly, I'm going to toggle off both of my raster image layers here, that PDF map and imagery, and I have a terrain grid in this workspace as well. So this is of the Augusta area, and we're using a shader that displays all our elevation values with a single color, but we've got some hill shade applied so we can see a little bit of texture here, particularly in this southwest corner. We can see some terrain variation just looking at our map in 2D. And I'm going to use that underlying elevation grid to texture my ortho image here. So again, I'm opening the raster options for a layer, this time that Augusta.jp2 imagery layer that I have. And down at the very bottom of our display tab, instead of choosing a specific blend mode, I'm going to use a little shortcut checkbox we have here to texture the map. And this is going to apply that light, that shading from our elevation layer to this image layer that we have. Again, just popping back into the raster options, I can maybe lighten the color intensity a little bit for this layer as well. And we can see the texture coming through a little bit more, particularly in this forested area in the southwest corner of our image here. Now that I've blended or textured our ortho image with our elevation data, I can also turn on our Augusta PDF, because remember we have some blending set there. So we can see not only that texture that we've applied, but the elements that we wanted to retain from our top layer, our Augusta PDF map, all displayed in Global Mapper. And here we get a more full picture of the study area that we're looking at here around the Capitol.
Yeah, that's excellent. And once again, I know we've had a few questions on exporting specifically, but it's a what you see is what you get when it comes to exporting. So in this case, these essentially 3 layers would be integrated into a single export, whatever that format is. So yeah, that's that blending tool. There's a number of other options in there, by the way. Any of you familiar with Photoshop or some of those procedures will probably be familiar with some of the other options in that drop down. But yeah, being able to work with multiple data sets concurrently. Quick question while I'm transitioning back to my screen again came in related to transparency setting. I think it was based on the previous feathering exercise. Question was, after the 2 layers have been feathered together, can you still adjust the characteristics of one or other? In other words, can you set a transparency? And yes, you can. They're still independent. Obviously, the transition was only applied to one layer because I applied that feathering to the high resolution layer. I can make it transparent. I can make the other one transparent, or whatever I need. The other option for transparency, by the way, is to choose a specific color or range of colors to be transparent, and that may work in certain situations as well. So the simple answer to the question is yes, you can still adjust those individual characteristics. So we went through a number of different exercises, which kind of collectively we could describe as editing raster data, modifying it in some way, modifying the visual characteristics, et cetera, et cetera, et cetera. Also, again, this goes back to a question that was asked previously about the process of rectification. There is an option to shift data as well. If you do simply need to shift a layer, you can do that by selecting it in the control center, and just you can define the extent. It's not rectifying, it's just literally moving it in a specific direction. So hopefully we're answering most of your questions. Those of you who are asking questions that, well, unfortunately we don't have a chance to answer verbally, we will definitely follow up with you. At this stage, I want to take a short break because just looking down through the list of attendees, I see a lot of familiar names. A lot of people I know have been coming to these sessions for a long time, not just this year, but over the course of many years. So we know there are a lot of long-time users in our audience today, and I know there's a lot of new users as well. I hear from folks who have attended some of our webinars for the first time recently. So we want to know who's here. We want to ask a question. I'm going to ask a very quick poll question of you. Basically, how long have you been on board with Global Mapper? How long have you been using Global Mapper? On your screen, you should now see a poll question. If you would take just a few minutes or a second or two, whatever it takes here, and let us know how long you've been using Global Mapper. You see the options over 10 years. Gosh, a lot of people are long-time users. I'm just watching the answers coming in real time. Right up to, I don't use Global Mapper as the final option there. And again, quite a few people are indicating that that's the case. So I'll give you a few more seconds just to answer the question, and I will go ahead and share the results with you in just a second so you can see who you're sharing this presentation with. Somebody just may put a comment in there that they've been on board for over 20 years helping Mike Charles with some of his initial development work. So yeah, long time user. Hopefully you're still learning some stuff about the software through these sessions. I'm going to go ahead and close the poll. And again, quick share here. You should be seeing it on your screen. You should be seeing the results. Special welcome for those of you who don't use Global Mapper. We're glad you're here. Hopefully you're learning a few things, and I'll give you some information at the end of our presentation where you can go ahead and grab a trial copy of the software, download it, put it through its paces, maybe play with some of the tools we're showing today, or indeed many of the other functions that are available. Thank you for your responses. Very interesting cross-section of users, Mackenzie. I think the most common are some of those 5 to 10 years experienced users, but hopefully, again, we're still introducing some new functionality for you. Okay, So if you look at our bulleted list here, we've gone through, as I said before, a number of exercises in editing. We're going to get into a little bit more of the analysis of your raster data, working with raster data and looking at some of those characteristics, maybe exploiting some of those characteristics a little bit. Mackenzie, I'm going to hand back over to you just very briefly, and maybe you could share a little bit of some of those analytical tools that are available.
Absolutely. So bringing up my screen again, I have yet another global mapper workspace open here, and it's the same area. We're still in Augusta, Maine, right by the Capitol. This image may look a little familiar to you now, but we're going to talk about some characteristics of the raster data that we're working with here. And as David mentioned at the beginning of the session, if we zoom in very, very close to our image at high zoom level here, we can start to see those individual pixels appear, those individual blocks. And David mentioned down at the status bar in Global Mapper, in the bottom left-hand corner of the screen, you can see the RGB value where your cursor is. But to get a little bit more information and see those values, we can use the feature info tool as well. So grabbing that, I can click and select a pixel in my data here. We can see that that pixel extent is now selected with my feature info tool, and we have our pixel information dialog up here. And this shows our 3 bands that come together to create the color that we're seeing on the screen. So we've got a red band, a green band, and a blue band here, describing our RGB color. You can see a little graph of those values here as well. And so that can be done to view, the characteristics of a pixel for any individual pixel within a raster image. To take a look at that concept a little bit more on a layer scale, I'm going to go ahead and open the metadata for my imagery layer here. So right-clicking and selecting to open metadata. We can see on our main metadata tab, we've got some fields describing the extent of our data, and scrolling down, we have pixel width and pixel height noted here. And that's good to know because as David showed at the beginning, that informs, the resolution of our data. For this image we're working with, we've got pretty high resolution data here. Our pixels are 0.5 meter by 0.5 meter, so we've got quite a bit of detail being captured. Moving over to the second tab of our metadata dialog, we see a histogram pop up. Resizing this window just a little bit larger here, we can see a breakdown of our red values throughout the image, the green values throughout the image, and the blue values throughout the image. And those are the components of the RGB values that create the color and color our pixels to make our image meaningful here in Global Mapper. So, looking at the statistics for a layer through this metadata dialog can give you a little more insight into the distribution of those color values. And you can always, choose to display this histogram in a graph window to leave it floating in Global Mapper or save it as an image. And you can export the data that goes into creating this histogram to a CSV file for maybe additional statistical analysis. So now that we're understanding that each pixel in this image has an RGB, has red, green, and blue values attached to create that color, we are going to, find the statistics for certain areas of our image. So some vector features that I have in this workspace are these grid cells. I've got 50 rectangular areas that cover the extent of the image that I'm working with here. I'm going to go ahead and select all of these area features. And I'll turn back on the imagery below those as well. Now, from my digitizer menu, I can add some attributes to these area features based on the image that I have displayed in the workspace as well. I'm going to calculate color statistics in my selected areas. Clicking on that, I'm prompted to select a color similarity measure. So how exactly do our RGB, our color values, need to match each other to be considered the same? Choosing a higher fuzziness value here may help, some areas of this green vegetation be considered just one green color as opposed to each small variation within the darks and light greens of the area. Clicking OK Global Mapper is going to work through and process, pull out key statistics based on the color values it finds within each of these areas. And it's going to save those statistics as attributes in our vector features here. And in just a minute, we'll be able to look at those attributes and determine, most common colors that are found within each of these tiles, these small study areas across our image here. So when that completes, I can deselect any of my area features, and I'll once again grab that feature info tool. And instead of selecting an individual pixel of my raster image, I'm going to select an area feature from my vector layer. In that resulting feature information dialog, we see some of those color statistics that were just generated by Global Mapper. Through this process, we've got our most present color, our average color, and a few other key values here describing what colors are found within this particular area. And these have been applied to all of the areas across the image here. Now, these are vector features, so we could use these values to show these different area features with a various color. I've actually gone ahead and done that. I have a copy of this vector layer here showing the average color for each of these individual areas. And what this really looks like here is a heavily downsampled version of my image. So we can see with the collection of green in the corner, we've got some vegetation, some blue and gray, green, blue tiles coming through here, so that maybe that's where our river runs through. And we've derived all of this information from that raster image and brought it into the vector world. So we can go ahead and add more attributes and work with these now as vector features, but the information behind them has been derived from that original image.
Yeah, and I think the big workflow in this is it can be queried. I mean, obviously now that we have kind of an aggregate color for a defined area, good for analyzing things like vegetation patterns over a wider area, where you have these vector blocks that not only contain attributes, but also render that based on this average color. I have to say, Mackenzie, thank you, and I don't mean to rush you here, but I'm looking at the clock, and it is, as always, not on our side. We will likely go a little bit late. I hope that's not too inconvenient for you, but there's a lot of really cool tools we want to make sure you're aware of. So with apologies, we may overshoot the top of the hour by just a little bit. I am going to actually work a little bit here with some a different type of raster data. When we kind of began the session, we talked about some of the online sources, and I mentioned land cover data. This is actually an example of some land cover data. It's a raster layer, let's get that clear, but it's a raster layer in which there is a little bit of intelligence in here, because first of all, there's a limited number of colors. This is a palette image where the palettes actually have an index value, and that index value also contains a description. So when you see colors in this way, it's almost like you're looking at a vector thematic map. These colors represent something. Now, to give you a little bit of geographic context now, we're in Albany, New York, looking at kind of the southern Adirondacks, just a little bit to the north. We're going to do a little bit of work with this data. First thing is very simple. Because we're working with raster data, kind of visual data, we want to display a legend. Now, we have used legends in many times for many of our workflows where we have vector data, but a legend will also apply when working with a color palette. And when I initiate that, well, first thing you'll notice a lot of redundancy in the native palette. So I've actually done a little cleanup, and I'm actually going to load this from a file. With apologies here, I'm going to go into my land cover folder, and I have a palette file I created, just basically a condensed version that reflects the actual colors that we're seeing on the screen. Click OK, and we'll click apply, and you'll see that now rendered on the side. So here we have an example of colors contained within a pixel that are now reflected in a legend that I have generated. So you can kind of do a little bit of visual analysis of the distribution of different land cover types. So legends obviously will apply to this appropriately formatted palette raster imagery, and this is an example of that. Now I'm going to turn off the legend for the time being because we're going to do a little processing of this data. I'll come back in here in just a few minutes and apply a modified legend, because what I want to do in my next workflow is a process called raster reclassification. Now, as you saw on the legend, there's a lot of different categories of data here. There's many different types of what we call developed. You'll see the area around the city of Albany has got different shades of red and pink. Outside of the city, there's other shades, yellows, browns, different shades of green, etc. So there's a lot of variation in the color, and it gets a little complex. So what I want to do is I want to consolidate some of these pixels. I want to take existing pixels and from them merge them together into new classes. Now, we've had a couple of questions on this theme. We've had a lot of questions today, by the way, one specifically about editing pixels. I'm going to show you how you can do that. So based on this image, I'm going to go to the analysis menu and I'm going to go to raster reclassification, a relatively new addition to Global Mapper. This is a tool that lets you take existing pixel values and reassign or assign a new color, or indeed with a palette, a new index value. Now, if this layer that I was working with was a standard imagery layer, an RGB layer, what we would see on this screen would be a histogram. We could divide that into a certain number of bins and use those bins collectively to assign new colors as needed. In this example, it's a little more straightforward. Because I have a palette image, there are only a certain number of colors, a limited number of colors available, so I can universally select all of those, or universally display all of those as noted here. Now, what I'm going to do is consolidate, as I said, all of these different land cover types into, I believe, 6 collective groups. First of all, you'll notice multiple variations on developed land, open space, low intensity, etc., etc. I don't need multiple colors. I want a single color, and I can do that by creating, first of all, my input values, and then the corresponding output values. I can define a description and choose a color if I choose. Now I'm going to go through this very quickly. I want to drag this over to just literally drag and drop, and you'll see my input values listed, my output index, just as a default, it's the first value from the input, and description, I'm just going to type developed. I'll repeat that for my forested areas. You'll see there's 3 variations on forest in this land cover data. Once again, drag and drop, and once again, I'll simply type in forested or forest or whatever you want. Scrolling down, what else is relevant in this area? Well, I see a couple of variations on agricultural land, pasture and hay and cultivated crops. Those I want to collectively render as well. And you'll see, by the way, when we do this, the color that's chosen by default is an aggregate color of the input values of the input colors. So we'll call this one farmland. And let's see, what else do we need? We've got wetlands here. Variations on the theme of wetland. I want to merge these together, and we'll drag and drop. And we'll call these, needless to say, wetlands. Almost done. There is a distinct category for open water. If I scroll to or move my dialog box slightly to the left, you'll see those very clearly, these open lakes here. I don't want to change those. I want to keep those as part of my display. So I just simply drag that one line and it will be replicated. No changes made, it's got the same color, etc. Now, so I've defined the target pixels basically that I want to render with these new consolidated colors. What about everything that's left? Well, I can put a new line in here and simply type other. I believe, I'm not sure if it is case sensitive, but I usually do it uppercase. Oops, one more time. And we'll put a description. Again, we'll make the description other. And I need to give it an index value. I'm just going to assign it index 1. And color, it's white by default, but let's make it a kind of a gray color. I don't honestly believe there's that many pixels of this color, but if there's a kind of a catch-all for anything that's left over, if you like. Let's go ahead and validate that just to make sure that the rules that I have applied here work. So again, I'm taking all of the colors in the source layer, consolidating them into these 6 colors that we will see in a new layer. I'll click OK on this. It asks me if I want to save these settings, and the logic would dictate I would in most cases, because I maybe want to apply this in a future workflow. In this case, I'm not going to. I'm going to click say no. And you now see a modified or a new version of that data where we only have 6 colors. We've merged the different types of forest together. We've merged the different types of developed land together as well. So we've actually changed the colors of the pixels, changed the index values, and created a new layer from that process. Once again, we might want to create a legend here, or assign a legend. And I'm going to go to the view menu. Let's go to my layout options, just a shortcut to get to where I was before. And this case again, it's a palette legend. It's not dealing with vector data. Once again, I have a pre-formatted version of this, condensed based on the colors that we have created here. Click OK, and we'll click OK again, and our legend now is displayed over here on the right side. So here's an example of reclassifying pixels, essentially assigning new colors to pixels based on some rules that I established in this process. Now, that tool has many, many applications beyond what I showed you. This is just one example of how that works, a very powerful raster processing tool. Now, while I have the screen, and again, we are reaching the top of the hour, but we're going to overshoot by just a little bit. There's a couple of additional workflows that we want to show. One is, in my opinion, one of the most powerful raster processing tools in Global Mapper. It's a tool that lets you capture data from a raster layer and render vector features. We're actually generating vector features. Now, based on my classifications, based on the colors that we're seeing, you can see I've got open water, et cetera, et cetera. And this obviously, again, was a vicinity around Albany, New York. I'm looking at farmland specifically here. These yellow colors collectively are areas that are designated as farmland. Let's say I want vector polygons representing these farmland areas. In Global Mapper, there's a tool that can be accessed from a number of locations. I'm going to go to the layer menu, create area features. Now, if you've ever encountered this, you may not know what it does because it's a little bit vague. Area features from equal values. Equal values can be either whatever the value of a pixel is. It could be a height value, it could be a slope value, or it could be a color value, which is the example we're going to use in our case. And area features in this case means vector polygons. So very simple workflow. Again, I'll make sure I'm using the appropriate layer here, my reclassified layer. And I can derive vector polygons from every color, but in this case, I want to specify a color. And again, scrolling through the original palette list, you should be one here called farmland. That is represented by these yellow pixels. I'll click OK for that. We don't need any fuzziness here, by the way. You can apply this in other contexts with standard imagery, RGB imagery, and a fuzziness is usually a good idea to give you a little more flexibility in terms of what's extracted. I don't need that in this case because all of the pixels are of this color. Let me limit the extent just in the interest of time, just a little bit of an area right around the city. Obviously, there's not a great deal of farmland, but maybe that's the issue. Maybe we want to target very specifically where farms still exist within the confines of the city. Maybe that's the analogy here. We'll click OK. And we should, in just a few seconds, see a new layer in the control center and see some vector polygons rendered on my screen. I'll just turn the vector layer on again, and you'll see now we're in the vector world. We have been able to extract vector features from a raster layer, in this case based on a very specific color match. There are many opportunities for that. We're using that tool, identifying different types of vegetation in some imagery, identifying buildings, etc. You're basically collectively grouping them together and generating your polygons as part of that process. Now, we did have another workflow that we wanted to share with you, but we have run out of time using some standard imagery. But unfortunately, Mackenzie, I'm going to have to bypass that one for now. And I kind of wrap this up with one final workflow. Another tool you may have noticed when I went to my analysis menu. Most of these analysis tools, by the way, are for working with terrain data. You'll see things like contour generation, view shed analysis, etc. But there's a group in here for working with raster data. We already used a pan sharpening. We've done our reclassification. You'll notice here as well, raster calculator. Now, this is, again, a very powerful tool that allows you to generate a new raster layer based on a formula that you apply to those values that we've been talking about that are present inside a pixel. Now, for this example, I'm going to shift geographically. Those of you who are geographically astute will recognize I'm here in South America, specifically western part of Brazil. I want to turn off that reference data. By the way, the background data is simply some streamed topographic data from my online services, which we referred to before. I'm going to turn that off now that we know where we are. I'm going to zoom in a little closer, and what we have here is at least visible, we have a single tile of Landsat imagery now, specifically in this case, this is the red band for some Landsat imagery from a very specific time frame. This is 1985. What I'm going to do very quickly here is to do a visual comparison as to what's happened in this area related to the vegetation that's present, because we're going to conduct an NDVI analysis. Many of you may be familiar with that normalized difference vegetation index, the ability to determine the relative greenness in an area by analyzing the absorption of the red band and the reflection of the near infrared band. You'll find that index, if you're going through this process, the index value increases when there's more greenness in this area. Now, I do have in this workspace both the red band and the near infrared band for the same area. Now, we perform this operation by taking the values in each overlapping pixel and performing a very simple mathematical operation. It's the red band minus the near infrared divided by the red band plus the near infrared, and that will give us an index value that will determine, it will reflect how much greenness is in this area. I would anticipate in 1985 there's a relatively high greenness in this area, and we'll go through the process and verify that. From the analysis menu, raster calculator. Again, we have our two layers, near infrared and red, just confirming those are the layers in question. Now, I'm going to call this layer NDVI. We're outputting a new raster layer, so I'm going to call it NDVI. Was it 1985? I said something like that, mid-1980s. And we're going to choose one of the predefined formulas. You'll see there are many variations on this idea of raster calculation. Again, derived from the numeric values that are embedded in each pixel. I'm going to choose NDVI. It's a simple one. There's a few variations even within NDVI, depending on the source data you're working with, the structure of that source data. But I'm going to use the very basic one again, band 4 minus band 1 divided by band 4 plus band 1. We don't know what those bands are yet. We'll assign those in just a few minutes. That's really all I need to do here, just making sure that we're applying the appropriate formula. We have a pre-configured visualization that will be applied, a shader that will be applied. The colors, in other words, will reflect what that index value is. You'll see that in just a second. And we'll click OK. And again, confirming that my red band, my band 1, is this one. My band 4, need to make some switches, is this one. If this was a multi-band image, by the way, you can choose the individual internal bands, but this is a single grayscale within each of these individual layers that I've loaded, just for visual clarity. This should work. We'll click OK. And when it completes, we will get a new raster layer, and you'll see it's almost entirely green, as we would expect. 1985, the scene was, as you see right now, lots of trees in this area. We're dealing in the rainforest, so everything looks good. There's a few little bits of noise here where there were some clouds. It was actually very hard to find imagery in this area where there were no clouds within this time frame, but I think I got one that looks reasonably well. Now, I've already done another analysis for the data from 2019, relatively recently, and hopefully you can see where we're going with this. If I enable the display of that layer, you can see things have changed quite drastically over that time frame. Greenness is still present. There is still green there, but this is cultivated land now. This is land where crops are growing. The intensity of the green return that was prevalent when we had a dense canopy is obviously gone. Now, the final analysis that we're going to perform on this imagery is to subtract one from the other to see how much has actually been lost. And once again, we can go back into the analysis menu, back into the raster calculator once again. And what I want to do is create a very simple formula. It doesn't matter what the name assignments are. I'm just going to choose band 1 and band 2, and as we saw before, we make the choice as to what each band is. I'm subtracting one from the other. It's just a little minus sign here. My custom formula is very simple. I want to subtract one layer from the other. I'll add that band. I'll use the NDVI shader once again because it'll show me where there's been positive change and where there's been negative change using the colors you see on the left side of my map view. So NDVI shader will work. It's a difference. I could rename the layer NDVI difference. If I wanted to take the time, we'll save a little time by not doing that. And again, we need to make sure that we're choosing the appropriate bands to subtract from and some from which to subtract. My band 1 is going to be my 2019 and my band 2, 1985. Now, again, when we run through this, it's literally running a mathematical process with overlapping pixels to visualize the difference between my NDVIs for 2019 as compared to 1985. And the takeaway from this very hasty workflow as an illustration of Global Mapper's kind of raster calculation is there's a lot of loss in greenness here. A few little patches where we see a little bit of increase in the naturally forested area that has not yet been cut. Maybe if I turn on some imagery here, it'll provide a little bit more visual clarity. Oops, I got image layer as well. So let me use my image swipe as Mackenzie had shown us before, and we can pull back and we can see what that actually looks like today. You can see the corresponding visual representation, but it's these index values now seeing, because all these blue areas are in the negative territory, we're obviously seeing a lot of loss in our greenness. Question, where did my Landsat data come from? You can access Landsat data from right in here in the online data. When I say access, we have some links under imagery, I believe it is. You'll see Landsat 8, the most recent Landsat, via Earth Explorer. This is a redirect to the Earth Explorer site. It'll actually take your current screen extent, transpose that into the Earth Explorer, and you can choose all of the current and legacy Landsat data right there and download what you need. So that's how I was able to get some data for this specific area. Okay, the final bullet on my list, and thank you for those of you who are patient and have stuck around here. I promise we're almost done. The finest bullet here is worth acknowledging, and the idea of exporting raster data. I don't need to spend a lot of time on this, but whatever we've done with whatever raster data we've worked with, whether that be something we've rectified, as Mackenzie showed us, maybe we've done some blending, or maybe we've done a little bit of feathering to improve the appearance. Regardless of what you've done, or regardless of the source data, you can render a new file. We've had a couple of questions on tiling raster data. I can show you that very quickly when we bring up the dialog box. Just as Global Mapper supports multiple formats of data in terms of the import process, raster data, similarly when you're exporting data, there are multiple raster formats supported as well. So if you're working with GeoTIFFs but you want to generate ECW files, you can absolutely choose whatever format you want when it comes time to export. And indeed, if your workflow is simply this conversion, data in, data out, you can simplify that either using a script or even using our little batch conversion tool. But having gone through the process of actually doing some editing and manipulating of our data, maybe we want to manually export it. I'm going to choose GeoTIFF as an example here. I'm not actually going to go through, but just to show you one example. When we select that, you'll see here we have options to define that file type based on whether it's a multiband or 8-bit palette image or 24-bit, whatever the characteristics that you need to define. The resolution is important. We talked about resolution right at the start. When you export, you can define what that resolution is. Maybe you want to dumb the data down a little bit just because you want to save some space. You can also define the compression during that process as well. One thing to note here is that you can also generate raster layers from your vector data. So if you have a vector layer, maybe it's a layer with building outlines, but you need it in a GeoTIFF form for whatever reason, you can generate an output layer from some source data, which is vector format, and generate, again, whatever format of raster data you want. Now, I'm not going to go any further with the, oh, sorry, I mentioned tiling, with apologies. Someone mentioned tiling. You can absolutely tile the data. There are options to tile it, as you see here. You can also apply tiles based on a pre-configured grid, maybe something similar to what Mackenzie showed us, where you actually have tiles that already exist. If that were the case, you can use those selected area features for your tiles. But tiling up imagery as into manageable chunks is definitely an option. And that, finally, there's a few people have stuck around. Thank you for those, again, who stuck around to the end. That is, again, a quick overview of Global Mapper's raster processing functionality. We probably could have split this into a couple of sessions, Mackenzie, or extended it to a couple of hours. I don't know. If you're interested in any of these tools, let me go back to or remind you of one of the slides that was there earlier. We go through all of these tools in our training classes and with some actual data and some actual scenarios, and spend our time to actually describe the dialog boxes. So if this is something you're interested in seeing in more detail, I mentioned we have some training coming up. Look on our website and you can get that information, sign up for the class, and again, we can give you more hands-on experience with some of these tools. But for today, and again, overshooting the top of the hour by some considerable amount. I think we've reached the end. If you're new to Global Mapper, and I know a sizable percentage of you are, because you said you'd never used it, and you're interested in some of our licensing options, orders@bluemarblegeo.com would be where you would send an email to find out what sort of licensing tool options are available, whether you want maybe a network license for your company, maybe a dongle license for if you want to share your license with other users. So go ahead and send them an email. If you have any questions about this content, I mentioned this at the start, maybe you're watching the recording, you want some clarification on some of the things that I went over very quickly, geohelp@bluemarblegeo.com is our tech team. They'd be more than happy to answer those questions. Please make sure you mention that you saw something in this recording, and they can make sure you get an appropriate response to your question. And finally, for those, 7% of you who have never used Global Mapper, bluemarblegeo.com. Go to the Global Mapper section. You can download a free trial today. You get a temporary license. You can put it through its paces, work with some of the scenarios that Mackenzie and I showed today. And breathe. Mackenzie, thank you so much for your help and for helping answer questions. I really appreciate you taking the time today.
Oh, you're welcome. I'm happy to be here. And as David said earlier in the session, for those of you who have asked questions live here, we will be, following up on those questions that we did not get to answer during the session today.
Yeah, I think some of our tech team, I'm looking at this, I'm scrolling through the list. There's a long list of questions. So it is great. I'm so glad you folks are engaged with these. But we'll get your answers directly. We'll also post a blog, hopefully within the next week or so, or whenever we can get to these, and we'll share that link with you as well. So you can see not only your questions, but all of the others as well. Folks, have a great rest of your day, and we'll see you next month when we talk a little bit about improving point cloud data. Have a great day, folks.